Have you ever paused to ask, how important are the elements in our daily life? From the air we breathe to the gadgets we rely on, from the water that quenches our thirst to the very makeup of our bodies, elements are the building blocks of everything around us. Each element, with its unique properties, plays a significant role in our existence and the functioning of our world. Let's take a moment to appreciate the extraordinary tapestry of life, woven together by these elemental threads. Consider carbon, the backbone of all organic compounds, the building block of life as we know it. It's in every cell of your body, in the food you eat, and the air you exhale. It's even in the very screen you're looking at right now. Next, consider nitrogen, the silent majority of our atmosphere, making up about 78% of the air we breathe. It doesn't just fill our lungs, but fuels our food production as a critical component of fertilizers. Then there's oxygen, the life-sustaining gas that fuels our cells, supports combustion, and makes up about a fifth of our atmosphere. It's in every breath we take, every flame we ignite, and every drop of water we drink. Fluorine, the most reactive and electronegative of all elements, is used in everything from nuclear reactors to pharmaceuticals. It flows in our rivers, strengthens our teeth, and even lights up our cities in neon signs. Speaking of neon, this element, named for the Greek word for new, lights up our lives in more ways than one. It's in the bright glow of neon signs, the cutting edge of laser technology, and even the icy depths of cryogenic refrigeration. Each of these elements, and so many more, work in harmony to create the world as we know it. From the microscopic to the cosmic, elements are the notes in the symphony of our existence. So let's embark on a journey to explore these elements and their fascinating stories, because understanding these elements gives us an insight into the very fabric of our existence. Starting with carbon, the basis of all life on Earth. This fascinating element derives its name from the Latin word carbo, which translates to charcoal. With an atomic number of 6, carbon is a cornerstone in the world of science and beyond. The uses of carbon are vast and varied. Most notably, it forms the backbone of organic compounds, making it an essential component of life as we know it. Furthermore, it plays a significant role in the production of steel, tire manufacturing through carbon black, and in high-tech applications such as carbon fiber. The discovery of carbon dates back to ancient times, but it was Antoine Lavoisier, the father of modern chemistry, who officially recognized it as an element in 1789. Now let's turn back the clock to 1985. In this year, 3 scientists, Mario Molina, Sherwood Rowland, and Paul Crutzen, received the Nobel Prize. Their groundbreaking research unraveled the role of a specific carbon molecule in the depletion of the ozone layer, a discovery that underscored the extensive and sometimes unexpected impacts of carbon compounds on our planet. And here's an intriguing fact about carbon. It possesses the highest melting and sublimation point of all elements. This unique property makes carbon indispensable in the creation of heat-resistant materials, with applications ranging from space exploration to everyday cookware. Thus, carbon, the element of life, has far-reaching impacts beyond what meets the eye. Moving on to nitrogen, an element that constitutes the majority of our atmosphere. The name nitrogen originates from the Greek words nitron and genes, which translates to niter-forming. This element, with an atomic number of 7, is not as inert as it seems. Nitrogen is an essential component in fertilizers, helping plants to grow healthy and strong. In fact, it forms part of every living cell, as it's a crucial component of amino acids, the building blocks of proteins. But its uses extend beyond the organic realm. Nitrogen is also used in various industrial processes, including the creation of stainless steel and in the production of electronics. Nitrogen has been known since ancient times, but its elemental nature was identified by Scottish physician Daniel Rutherford in 1772. Rutherford conducted experiments involving a small animal in a confined space with a limited amount of air. He found that after a while, the air in the space would no longer support combustion or maintain life. However, it wasn't poisonous, as a candle could burn in it for a short time. Rutherford had discovered nitrogen gas, which he initially called noxious air or phlogisticated air. The story of nitrogen's discovery led to a significant realization in the 18th century, altering our understanding of gases. Scientists found that nitrogen doesn't support combustion, unlike oxygen. This led to the discovery of the concept of gases that don't react, a crucial milestone in the field of chemistry. And here's a fact that might surprise you. Nitrogen makes up about 78% of Earth's atmosphere. Despite its abundance, nitrogen doesn't react readily with other elements. This characteristic makes our atmosphere stable, allowing life to thrive. So, while nitrogen may seem unassuming, it plays a fundamental role in our lives. From the air we breathe to the food we eat, nitrogen is everywhere. Nitrogen, though not reactive, is a vital part of our existence. Next in line is oxygen, the breath of life. This miraculous element, number 8 on the periodic table, is the lifeblood of our planet. Its name originates from the Greek words oxy, meaning acid, and genes, meaning forming. The discovery of oxygen was a joint effort independently achieved by Carl Wilhelm Scheele and Joseph Priestley in the year 1774. Oxygen plays a monumental role in our existence and our daily lives. It is the very essence of respiration, vital for the survival of most life forms on Earth. It is also a critical player in the process of combustion, pivotal in everything from lighting a match to powering a rocket. Beyond these fundamental roles, oxygen also finds its place in various industrial processes, contributing to the development and growth of human civilization. The story of oxygen's discovery is an intriguing one. Joseph Priestley, one of the discoverers, initially referred to oxygen as dephlogisticated air. He was yet to realize the critical role this element played in the process of combustion. This early misstep underscores the collaborative nature of scientific discovery, as it was through the combined efforts of many minds that the true nature of oxygen was eventually understood. Here's a fascinating fact about oxygen. It was the first element ever discovered that supports combustion and respiration. This discovery was groundbreaking, and it fundamentally transformed our understanding of the world around us and the processes that sustain life. From the deepest depths of the ocean, where marine life relies on the dissolved oxygen, to the highest peaks of the tallest mountains, where climbers might struggle with the limited oxygen, this element is a constant yet often overlooked companion. It's in every breath we take, in every flame that flickers, silently fueling life and energy on our planet. Oxygen, a silent yet powerful element, fuels life on Earth. Lastly, we have fluorine and neon, the reactive and the radiant. Fluorine, deriving its name from the Latin word fluere, which means to flow, is noted for its atomic number of 9. This element is widely used in the production of uranium hexafluoride for nuclear reactors, the pharmaceutical industry, and as a fluoridating agent that helps prevent tooth decay. Fluorine's discovery is credited to Henri Moissan in the year 1886. Moisson's pursuit of isolating fluorine was no easy task. He endured challenging conditions, using a potent mixture of potassium fluoride and hydrofluoric acid in platinum vessels. His determination bore fruit, and thus the world came to know fluorine, the most reactive and electronegative of all elements. Now let's move on to neon, the radiant. The name neon is derived from the Greek word neos, meaning new. With an atomic number of 10, neon is primarily used in neon signs, lasers, and as a cryogenic refrigerant. The discovery of neon is attributed to Sir William Ramsay and Maurice Travers in the year 1898. An interesting tale surrounds their discovery. While Ramsay and Travers were engrossed in studying liquefied air, they stumbled upon neon. They realized that neon was distinct from other gases they were studying, marking a significant milestone in their research. Neon is best known for its distinctive bright glow when an electric current passes through it. This property has been capitalized on in the creation of neon signs, which have illuminated countless cityscapes around the world. Fluorine and neon, each with its unique properties, remind us of the diversity and richness of the elements that make up our world.